Hi, welcome to my channel, The Magic of Math, where we master math one video at a time. Today, our lesson is on how to subtract rational numbers. That's also your objective, to subtract rational numbers. Here's the question I would like you thinking about as we go through the lesson today. How can you use what you already know about subtracting integers to subtract rational numbers? So today's lesson is going to be a bit of a mashup. We're going to take what we know about subtracting integers and apply it to what we know about subtracting fractions and decimals. So our subtracting rational numbers rule is identical to our subtracting integers rule. Let's review that. So the subtracting rule is, to subtract, we're going to change the subtraction sign to addition and then add the value that follows with an opposite sign. So, or we can say change to addition and add the opposite. So here's a visual of that. We're going to keep our first value, change subtraction to addition, and add the opposite value. So this is what it would look like with an example. I have rational numbers here and I'm subtracting. So let's go through what this looks like. I'm going to keep this first value and just rewrite it. I'm going to change the subtraction sign to addition. And then we're going to make the second value the opposite. So if this is negative 4.7, it's going to be positive 4.7. And then you would simply just add the decimals. Let's practice. So we're going to find the difference, negative 8.6, subtract negative 7.2. So our first step is to rewrite this to be addition. So I'm going to keep negative 8.6, change subtract to add, and negative 7.2, the opposite, is positive 7.2. So I have now just to go back to my integer rules or my adding rules, and we're going to do the same thing that we learned in the previous video for adding rational numbers, which is identical to adding integers as well. So I have two different signs. The absolute value of negative 8.6 is larger than the absolute value of 7.2. So that tells me that my difference is going to be negative. Now I'm going to take my larger absolute value and I'm going to subtract my smaller absolute value. 6 subtract 2 is 4. Bring down the decimal point. And 8 subtract 7 is 1. Remembering that we made this plan and it's going to have a negative difference of negative 1.4. Now let's try our fractions. So the first thing I'm going to do is rewrite this subtraction to be addition. I'm going to keep negative 2/3, change subtract to add, and the opposite of negative 1/2 is positive 1/2. So now I'm ready. I need to get a common denominator so that I can see which absolute value is the largest. My common denominator, seeing as 3 and 2 are prime, would be 6. So let's go ahead. I have my fraction, my negative 2/3 here. To get a denominator of 6, I need to multiply both the numerator and denominator by 2. And here's my fraction of 1/2. And in order to get a denominator of 6, I need to multiply both numerator and denominator by 3. Let's multiply. 2 times 2 is 4 over a denominator of 3 times 2 or 6. Don't forget that negative sign. 1 times 3 is 3 and 2 times 3 is 6. So now I'm ready to identify that negative 4/6, the absolute value of that, is larger than the absolute value of 3/6. So that means my difference is going to be negative. So I'm making a plan so I don't forget that. Now I need to subtract the smaller absolute value from the larger. So that we're going to keep our denominator of 6. 4 subtract 3 is 1. So 1/6, and don't forget your negative sign. You should always make a plan. Negative 1/6 is our difference. Your turn. I would like you to pause now, write down these problems, remember your rule, rewrite them to addition, and then use your adding rules to find the difference. Go ahead and pause. Come back when you want to check your work. Welcome back. So let's rewrite these. Keep the first value, negative 8.4, change subtract to add, and the opposite of 6.7 is negative 6.7. They have the same sign, so I'm going to always know that my difference, when I add these, it's a sum, but I'm really finding a difference of the original. But when you add two values with the same sign, you keep the sign. So now I just need to add 8.4 and 6.7. 4 plus 7 is 11. So 1, carry the 1, bring down the decimal point. 1 plus 8 is 9, plus 6 is 15. And don't forget, your solution has to have that negative sign, negative 15.1. Let's see how you did with the fractions. One thing I insist that my students do is change all mixed numbers to improper fractions, because we're working towards solving algebraic equations and we're not going to see mixed numbers there. They're going to be improper fractions. So I'm going to change this in the next step. 3 times 3 is 9, plus 1 is 10. So this would be written as negative 10/3. I'm changing subtract to add, and the opposite of 5/6 is negative 5/6. They have the same sign, but I need a common denominator. But I'm still going to make note here that I'm going to have a common denominator of 6, so I need to multiply both the numerator and the denominator of the first fraction by 2. Let's multiply. 10 times 2 is 20 over 6. Same sign, so I know that my answer is going to be negative. So I'm going to keep my denominators, but just add my numerators. 20 plus 5 is 25. So negative 25/6, and that's in simplest form because 25 is 5 times 5, and there are no factors of 5 and 6. I do not ask my students to to rewrite as a mixed number. They must simplify, but you can leave it as an improper fraction, in my classroom anyway. Your turn again. I would like you to pause the video, solve, and come back to check your work. Welcome back. Let's see how you did. So we're going to rewrite negative 17.5, change the subtract to add, and the opposite of negative 17.5 is positive 17.5. Now, I hope you recognized these are opposites. So the additive inverse property tells me that when I add opposites, I get 0. Now let's try this one. Let's rewrite. 5/6 we're going to keep, change subtract to add, and the opposite of negative 1/6 is positive 1/6. They're both positive. They already have a common denominator, so I just need to add my numerators. 5 plus 1 is 6 over our common denominator of 6, and 6 over 6 simplifies to 1. Your turn again. Go ahead and pause, solve, and come back to check your work. Good luck. Welcome back. So let's rewrite 0.3, change subtract to add, and the opposite of 0.8 is negative 0.8. I have two different signs. So the larger absolute value is negative, so I'm going to make note that my solution will be negative, taking my larger absolute value and subtracting my smaller absolute value because there's two different signs. So set this up to subtract. 8 subtract 3 is 5, and then we just bring down our decimal point and add that 0. And remember, it's negative. Over here, I'm going to rewrite, and when I rewrite, I'm going to turn both of these mixed numbers into improper fractions. 3 times 2 is 6, plus 1 is 7, so that'd be 7/2. Change to addition, and this will be negative. 4 times 4 is 16, plus 1 is 17/4. So now I need a common denominator. So I see I have 4. If I multiply this fraction by 2 over 2, I get a denominator of 4. So let's do that. Here's my 7/2. I'm going to multiply both the numerator and denominator by 2 to force a common denominator. Let's multiply. 7 times 2 is 14 over 4. So now I'm ready to identify what my solution will be. The larger absolute value is negative. So I need to make note of that. I never skip this step. Now I'm ready. I'm going to take the larger value, which is 17, subtract the smaller, which is 14, keeping my common denominator. 17 subtract 14 is 3. Don't forget, it has to be negative 3/4. fourths. Let's look at some real-world problems that involve subtracting rational numbers. Let's talk about temperature. Think of a thermometer as a vertical number line. The temperature outside was negative 20.5 degrees Fahrenheit at 6 a.m. Let's put that on our thermometer. So right about here. At recess time, the temperature was now 22 degrees Fahrenheit. Let's go to our thermometer. It's rising, right? It went up, it got warmer, and now it's about 22 degrees. And we're being asked, how many degrees did the temperature change? So we're now at 22, and if we subtract what we started at, we're going to get our answer. So 22, keep, change subtraction to addition, add the opposite. When I add these two values, I get 42.5 degrees Fahrenheit. Now let's talk about this for just a second. I started at negative 20.5. My temperature went up 20.5 to 0, and then it went up another 22 degrees. Doesn't that make sense? 22 plus 20.5 is 42.5 degrees Fahrenheit. So we wanted to know how much it increased. So it was a positive 42.5 degrees Fahrenheit. Your turn. I would like you to try this one and find the temperature change. Please pause and come back when you're ready to check. Welcome back. Let's see how you did. So the temperature outside was 3.5 degrees Celsius at noon. So we're going to put 3.5 degrees Celsius and know that it went down. At 8 p.m. it was negative 2.7 degrees Celsius, and now we need to find our change. So we're going to start with negative 2.7 degrees and subtract where we were in the morning and rewrite. Keep, change, opposite. Same sign, so I just need to add and keep the sign. So 2.7 plus 3.5, line up the decimal points. 7 plus 5 is 12. Bring down, put the 2 and carry the 1. Bring down our decimal point. 1 plus 2 is 3, plus another 3 is 6. So our temperature change, remember they were both negative, it dropped, right? It went down, so negative 6.2 degrees Celsius. So that makes sense though. It went 3.5 and another 2.7, but it's a drop, so it's negative 6.2 degrees Celsius. There you have it. That's how you subtract rational numbers. Don't forget to rewrite subtraction to addition. Keep, change, opposite. Thanks for joining me today at the Magic of Math, where we master math one video at a time, and I hope you have a great day.